Let me hope you are doing fine, whoever is listening. Before I start any further, we are going to go through the references here in submath. So those ones are some of the references that you must be having. Nowadays, there are Ugandan authors who came up with their own textbooks there. So you can also look at them. They are there available in the market. So the subsidiary math has parts. We have the pure mathematics part, statistics part. Today we are going to begin with the pure math part, and that is the topic of indices, logarithm, and surds. So we are going to begin with the indices, and we are going to begin by defining what an index is. So an index is a power or exponent which is raised to a number or a variable. That means it tells you the number of times a number multiplies itself. The index is the singular form and the word indices is the plural form. An example we are having there is the 9 power 3. That is, the 3 is the power of 9. That 3 of ours is the power of 9. This 9 power 3 means we multiply 9 3 times. So that is 9 times 9, then times 9. So this is what I said earlier on, that index tells you the number of times a number is multiplying itself. So the 9 power 3 shows that 9 multiplies itself 3 times. So we are going to look at laws of indices, simplifying expressions using laws of indices, then solving the equations that require use of indices. So when we go to the laws of indices, we are saying suppose that m, n, a, and b are integers. Remember, the integers are either positive or negative whole numbers. So the first law there is multiplying numbers of the same base, that is m and m. We keep that base, then we add these powers here. So we have added the powers there. For example, if I have 4 squared times 4 power 3, so I write my base as the 4, then I add the 2 to 3 to have 4 power 5. The second law there is when we are dividing numbers of the same base, we keep the base and then we subtract the powers. So we are having our m power a minus b. An example, if I have 8 power 12 and then 8 power 7, this one is equal to 8 power 12 minus the 7, that is the base which was 8. We are keeping it there. Then we are subtracting its powers, which was 12 and 7. Finally, when you subtract the 12 minus 7, you get a power of 5. So the answer becomes 8 power 5. When we go to the next one, we are having a base, that is m raised to a. Now the a is the power, and outside the bracket there we are also having the power, which is what? Which is b. Now in this case, when we remove the bracket, those powers are going to multiply each other. For example, if I have 3 power 2, then brackets power 6, when I remove the bracket, the 2 has to multiply the 6 to have 3 power, the 2 times the 6, which is 3 power 12. Or if I have, then outside the bracket, we are having a 3. When I remove the bracket, the negative 1 has to multiply the 3 right there. Now, when we go to the next one, in O level, they used to tell us, or in primary, that any number power 0, that number is a 1, and any number power 1 is that very number. The m power 0 is equal to 1, then n power 1 is exactly the n. For example, if I have 12 power 0, that one will give me 1. 7 divided by 2 power 0, that one will also give me 1. Also, even if I have a big number like 10,000 power 0, that one is a 1. And if I have any number power 1, that is the 3 power 1 there, that one we're going to be having a 3. And also 100 power 1, we are having a 3 right there. When we go to the fifth one, we are having a base raised to a negative power, that is raised to negative m. Now, if we want to make that power positive, we just take the reciprocal of the number of all of the base, and you also keep the power, and now the power is going to be a positive 1. So m power negative a is equal to 1 all over m power a. Or if your power is positive, when you take the reciprocal of the base number, the power has to be now a negative. An example, 6 power negative 5 is equal to 1 all over 6 power positive 5, and then 7 power positive 2 is equal to 1 all over 7 power negative 2. The sixth one, we are having m power 1 all over n. So the 1 all over n is the nth root. For example, if we say the square root, if we say the cube root, if we say the fourth root, fifth root, and so many others. So the m power 1 all over n becomes now the nth root of m. An example we are having is the 8 power a third, and the 8 power a third can be expressed as the cube root of 8. The 125 power a fifth can be expressed as the fifth root of the 125. When we go to another one there, we are having the power is the same, that is power a, and then the bases are different. So we can factor out that power, and then we multiply the base numbers. As on the right, we are seeing that the m now is multiplying the n, then our power is just right outside there. An example we are having there is the 4 squared times the 3 squared. We can factor out the square, then we multiply 4 times the 3 to have inside the bracket we are having the 12. Then we come and put our power there, then finally we get the answer of the 12 squared as the 144. We can have one where both bases are different and they are dividing each other, but their power is the same. So we also factor out that power right there. That is, if I have my m power a, then n power a, then I can rewrite that one as m divided by n power a. So don't fear about me beginning with this, and then when I'm explaining, I'm ending with that. We can start it either way, as we are going to be seeing in the examples. An example there, we are having 7 all over 9 then squared, is that when we remove the bracket, the power is going to distribute on the 7 and it's also going to distribute on the 9 to have the 49 there as the square of 7 and 81 as the square of 9. Then we go to 1, which has a combination of the nth root right there and then the power which is ever left outside the bracket. Beginning the m power b all over n, the 1 all over a is the 8th root. Now if you remember this other law here, then the b can remain the power of the base, or we can first get the 8th root of m, then thereafter we power it to this other power which is outside the bracket. An example there, we have 64 raised to 2 all over 3. Using this one, on substituting here, I'm having the cube root of the 64 and the 64 is squared. So I first square the 64 to have the 4096. Then I get the cube root of that one as the 16. Or we can have the 64 power 2 all over 3 as we first take the cube root of the 64, which is a 4 there, then leaving the square outside, then thereafter we square the 4 to get the 16. Then we go to simplifying index expressions, and then we just go right away into our examples. So example 1 says simplify the following, leaving your answer in fraction form if you find any number forming a fraction. The part A is the 27 all over 8 power negative a third. So what we are going to do, we are going to use one of the law that told us to convert the power into a positive by getting the reciprocal of whatever is inside the bracket. So the reciprocal of 27 all over 8, that one is going to be 8 all over 27, and now the power is going to become positive, just like here. Then we are going to prime decompose on the next step 8 and then the 27. Prime decomposition, I mean prime factorization. Prime factorization, I mean writing a number as a product of its prime factors. So using the ladder method, briefly like here, 8 divided by 2, we have a 4. And also the 4 divided by 2, we shall have a 2. Then also lastly, a 2 divided by a 2, we have a 1. Therefore, our 8 is equal to 2 power 3 right there. That's what we call prime decomposition. Then we also prime decompose 27. When we prime decompose 27, we shall have 3 power 3. Then we come and substitute them here where there is 8 and where there is 27 to have 2 power 3 there and 3 power 3. Now the next step, we are going to open the bracket by letting our power outside the bracket to multiply the powers of the bases which are inside the bracket. So that is 3 times a third there, and also in the denominator 3 times a third there. Then we are going to simplify the powers there to have the 2 power 1 and 3 power 1 like that. Then we said any number power 1 is that very number. Therefore, we rewrite the answer as 2 all over 3. Part B, which is m squared n power 5 times the m power negative 1 times n power negative 2. Then outside the bracket, we are having a power of 4. So what we are going to do, the first step, is to make this power outside the bracket to multiply the powers of the bases which are inside the bracket. So opening our bracket there, the 4 is going to multiply the negative 1. Then also the 4 is going to multiply the negative 2 there. Now when you multiply 4 times the negative 1, we shall have the negative 4 right there. Then when we multiply this, we shall be having a negative 8 right there. Now, multiplying numbers of the same base, we said we are going to add the powers. So the next step, we are going to write 1m, then we add that power 2 to power negative 4, and also we write 1n, then we add the power 5 to power negative 8. So now we are having something like that, the base raised to the addition of those powers and the base n raised to the powers there. So when we add the 2 plus the negative 4, we are going to get our negative 2. Then when we add the 5 plus the negative 8, we are going to have our negative 3. Therefore, we can leave our answer like this, or we try to rewrite this expression expressing the powers as positives. So we finally write that expression as the 1 all over the m squared times the n power positive 3 right there. Then we go to part C. We have x power 4, then we have x power negative 2, divide by x power 2, and x power negative 8 right there. So in the numerator, we are having base numbers which are the same. So we are going to write one base and we add the powers. Even in the denominator, we are still having the bases which are the same and they are multiplying each other. So we write one base, then we add the powers. So which is that the x power, the 4 plus the negative 2, then the x power 2 plus the negative 6. When you add the powers there, we shall have x power positive 2, and then when we add the power there, we shall have x power negative 4. So now we have two numbers of the same base. Yes, that is the x. So what we do is to write one base, then we subtract the powers, that is 2 minus the negative 4. So the x power the negative 2 minus minus, this minus minus, you know that it becomes a positive. Then we get the answer as x power the 6. We go to part D. Our part D, we are seeing our base there as the a in the numerator and also in the denominator. We are having our power 1 all over n, then power negative n, then power n plus 1, then divide by n. So in the numerator, we are going to first subtract the powers there. That is the 1 all over n minus the negative n as here. Then we keep the denominator as the way it is. Then here, negative times negative, you know we shall be having a positive, that is a power 1 all over n plus n. So now the power here and the power there, they are going to subtract each other on the next step, which is this, the a power 1 all over n plus n, then minus the power which was in the denominator of a. So now when you look at the powers there, there is this n which doesn't have a denominator, but we take the denominator to be equal to a 1, just like that. And then when you look at the denominators, the other denominators, we have n and n there. So the LCM is going to be n. Now we need to multiply through by n. When we multiply through by n, here, for example, times n, then even there, the multiplication of n, even there, the multiplication of n. So the n here is going to cancel with that n right there to have a 1, which is here. The n here times that n, we are having the n squared, which is right there. Then the n here is going to cancel out with that n to have the numerator there, which is n plus 1. But in this case, we open the bracket right away, so the positives are going to become negatives. Now we add the like terms, that is the 1 here, the positive 1, and the negative 1. One is positive, one is negative, and they are of the same magnitude, so they cancel out to have n squared minus n all over the n. Then here we are having a factor of n, so when I move it out, I'll be having n just like that. Then inside, the n squared now condenses to n, and the n condenses to a 1 to have this. So the n here is going to cancel out with the n there to have a power n minus a 1. So we have simplified the expression there. Now we go to number 2, evaluate the following, and we're going to start with part A, which is 100 power 1 whole number and a half. We are going to first convert the 1 whole number and a half into a mixed fraction, that is the 1 whole number and a half can give us 3 all over 2. So the 100 power 3 all over 2 now, we are going to express the 100 in terms of 10. So as we have 10 squared, why are we writing it like that? Our aim is to kill this 1 all over 2 right there. And then now the next step is to multiply the powers. That is, when you remove the brackets, the powers are going to multiply themselves. So that we have the 2 times the 3 all over a 2 right there. Now when you simplify this, we shall be having a 10 power a 3. So the 10 power a 3 is the same as multiplying 10 3 times, and the answer gives us 1000. As simple as that. Now we go to part B. Our part B is 27 all over 1000, and then in brackets power negative a third. We said when you want to make your power positive, take the reciprocal. So the next step we shall be having 1000 divided by 27, then power positive a third there. Then now, because it is a third, 1 all over 3, I'm anticipating, or I want to make these bases to be possessing powers of 3, such that when I open the brackets, the 3 multiplies with the third and it kills the third there. So the 1000 from the previous example, we can see that the 1000 can be expressed as 10 power 3, and also the 27 we area on so that it can be expressed as 3 power 3. Then power our a third right there. Then now the next step is to open the brackets. That is, the power is going to multiply the power of 10, and also the power third is going to multiply the power of 3 right there. So this is what I'm talking about. And then also in the denominator, then when you simplify that, we shall be having 10 power 1 and 3 power 1. The 10 power 1 is the same as just 10. That is, we said any number power 1 is that very number. So the 10 power 1 is the 10, and the 3 power 1 is the 3. When we go to part C, we are having our 8 as now the 2 power 3. Then the 4, we prime decompose it to 2 power 2. 32, when you prime decompose, it gives you 2 power 5. Then the 16, when you prime decompose, it gives you 2 power 4. Keeping now their powers there, the power there, the power there, the power there. We keep it the way it was as in the question, but we create brackets not to confuse us. Now when we open the brackets, the 3 multiplies the sixth, the 2 multiplies the third, the 5 multiplies the sixth, the 4 multiplies the 12th, the 3 will reduce the 6, and then the base will be having a power a half. Then the 2 times the third, there's nothing is going to reduce there, so it will be the base power to 2 all over 3. Then the same applies here. The 5 times the 6th, nothing will reduce there, but here the 4 will reduce the 12 to a power of 1 all over third. So we are having that 2 power half, 2 power 2 all over 3, 2 power 5 all over 6, 2 power a third. Then now in the numerator, we are going to write one base, then we add these powers there. The same applies in the denominator. We write one base, then we add the powers there. So we are having the 2 power, the addition of the powers, and the same applies in the denominator. Now when you add in the numerator, or when you try to simplify, the LCM of 2 and 3 is the 6, the one you see here. Then when you multiply times 6 here, and then also 6 there, we shall be having a 3 plus a 4. Then when we go to the power of the denominator, we are having the LCM of the denominator as 6. So we write the 6 times 6 here, then also times 6 there, to have the 5 plus the 2 when you try to simplify. Now we are going to add the power here to come to a 7, and also the power here to come to a 7 all over 6. So we are having that 2 power 7 all over 6 divided by 2 power 7 all over 6. So when you try to look at those two things, the denominator and the numerator, we are seeing that we are having the same number in the numerator and the denominator. So we can say the final answer is a 1. So when we go to part D, that is the 3 into the 2 power n plus 1, then minus 4 into the 2 power n minus 1, then divide by the 2 power n plus 1, then minus the 2 power n. Now here, don't get confused of this minus. I know some students, they are going to say in the denominator that is going to be 2, then you divide the powers. No, that one is very wrong mathematics. But we are going to see a way of reducing or simplifying that expression there. When you try to look at the 2 power n is appearing there. Even here, there is 2 power n embedded there, 2 power n embedded there, 2 power n embedded there. So we are going to try and see how to reduce that expression or pull out the 2 power n such that it can cancel out both in the numerator and in the denominator. So rewriting this one here as the 2 power n times 2 power 1. Remember, we said if we are multiplying numbers of the same base, we write one base, then we add these 2 powers. So from the previous step there, that is the addition of the powers. Now we are just reversing the law there. The same applies here. We are reversing the law. The same applies there. We are reversing the law. When we come here, the 2 power n, this 2 power n in the previous, or from the question, we had a plus 0 because it is not there, but we are trying to create it. Now, a number power 0, we said it will be a 1, if you remember. So that is why this 2 power 0 is coming in there, and then later on we write it as a 1. So on the next step, we want to factor out this 2 power n. But before we factor it out, we are going to make the 2, the 3 to multiply the 2, the 4 to multiply that 2 power negative 1, and then we see what to do next. So when we pull out this and also that, we shall remain with the 3 multiplying the 2 power negative 2, just like I've said, and also the 4 is going to multiply the 2 power the negative 1 there. So now we are going to multiply that to get the exact value. We multiply that to get the exact value. Even in the denominator, we have pulled out that 2 there, and then when you try to create the brackets, you can see that we remain with the 2 power 1 and also the 1 only here in the denominator. So now here clearly you can see that the 2 power n in the denominator there can cancel out with the 2 power n in the numerator there, because all of them, they are outside those big brackets. Then you evaluate what is inside in the bracket in the denominator, and also what is inside in the bracket in the numerator. The 4 is now going to be expressed as a 2 power 2. Then on the next step, we write one base, that is the 2, then power 2 plus the negative 1 to have a 2 power 1 just there, and any number power 1 is that very number. So the 2 power n cancels out to have 6 minus 2, and finally we get the answer as a 4. Our next part E is right there, square root of 9 in brackets power 3 times the 4 power half divided by 2 squared. Now we want to simplify this, and also you see that the 2 is somehow related to a 4, because when you get a 2 squared gives you a 4. Then the square root of 9, we are going to say 9 is the same as 3 squared. So the 3 squared, the square is going to cancel with the square root, because we said that the square root is going to be always a power a half. And when you multiply a half times the 2, the result here you will be having a 1. So this is what I'm talking about. The 2 times a half. Then we are keeping our power there. The 4, we made it a squared right there. Then when you open the bracket, we shall be having 2 times the power which was outside. So let us see what we get in solving here and also simplifying there. The result of this, we are having a 1 times the 3. Then the result of this, we are having a 1. Then the numerator is keeping just the way it is, but later on we shall see that the base here and the base there are the same, so we are going to subtract those powers there. And also this one here, when you multiply, we are going to see the result. So the 3 power, the result here, we have said it's going to be a 3. Then also here the bases are the same. We are going to say that that is a 2 minus the 2 here, because I'm beginning with the base which is down. That is why I'm saying power 2 minus the power of the base which is in the numerator. Then when you simplify this one here, we shall be having 2 power 1, which is in the numerator there. When you simplify, the 3 power 3 is the same as 27. Then denominator, the 2 power 1, which is just finally the 27 all over the 2. Then now we go to equations involving indices. So our example 1 there, we have to solve for m in our part A, that is the 3 power negative m is equal to a 9. So what we are going to do on the right hand side of the equation, that is our 9, we are going to express it as a power of 3, such that both sides of the equation have the same bases. Then thereafter we can equate the powers. So when you try to make a 9 to be having a base of 3, we are having 3 squared. Then on the next step, we just say that our power here is the same as our power there, simply because the base numbers are the same. Now we have the negative m to be equal to a 2. The next step, we are going to multiply both sides by negative 1 so that we get a positive value of m. And when I divide there, the negative 1 will make the m positive, and then the negative 1 on the right hand side will make the 2 a negative, to have the answer of m as. So now when we go to our part B of number 1, so the 64, we try to draw a ladder method here so as to express it in terms of a 4. So when I divide 64 divided by 4, I'm having a 16. Again, the 16 divided by a 4, I'm having a 4. Again, the 4 divided by a 4, I'm having a 1, which implies that the 64 is equivalent to 4 power 3. To have the 4 power k to be equal to 1 all over 4 power 3 now. We are seeing that the right hand side, this is the right hand side, it is having a fraction. Then we find ways of making that fraction to be in the numerator. Remember when we said that if you want to make the reciprocal of the base, you make the power negative. This is what we are going to apply here. So the reciprocal of 1 all over 4 is going to be 4, but now our power is going to be a negative, which is that the 4 power k to be equal to the 4 power the negative 3. So from there, we just equate the power k to the power a negative 3 to have our value of k as. So when we go to the next part, the part C, you first look at the bases. If you can make the bases to be uniform, that is, the least base on the left hand side is a 2, which is already there. This side of the right hand side of the equation, we are having 4 and then the 8 plus our power outside the bracket. But before we think about that power, let's first make these two to be having the same base or a uniform base as the base on the left hand side of the equation. So the 4 is 2 power 2, and then also the 8 is 2 power 3 right there. So the 8 had a power there, so the 3 is going to multiply the x on the next step, which is that. Then also the 3 which is outside is going to multiply that, and also the 3 which is outside is going to multiply that. This is what we have here, 2 power 2 times 3, and also 2 power 3 times x times a 3. So when we get this result, we are having 2 power 6, and also that result there, we are having 9x. Multiplying numbers of the same base, that is, we are still on the right hand side of the equation, we are going to add the power 6 to power 9x, which is that one there. Then at this moment, we are having the bases are the same. Then we can equate the powers on either side of the equation. So the 4x minus 4 is equal to 6 plus the 9x. So from here we correct the like terms, that is, we correct those having x's and those constants there. The 6 going the other side of the equation is going to be a negative, just like that, and the positive 4x going the other side of the equation is going to become a negative right there. When we add on the left hand side, we are having a negative 10. Then we add on the right hand side to have a positive 5x. Now we are going to divide both sides by 5 such that we get the negative 2 to be equal to x, which can be rewritten as x is equal to negative 2, and the equation is solved. When we go to the next part, 3 power n times 3 squared, then to power negative 2 all over n is equal to a 1. On the left hand side of the equation, we are seeing two bases which are the same. Yes, so what we are going to do, we are going to first simplify this by multiplying these powers, and then we add the powers there, keeping the base as 3. But this side, the 1, remember we said that any number power 0 is a 1. So our 3 power 0 is a 1. Therefore, we shall be substituting this 1 as 3 power 0 right there. When we open these brackets, the 2 is going to multiply the negative 2 power n, then the 1 I've said we are going to substitute it as that. Then we are going to get the result of this as the negative 4 divided by n, which is that. Then we add this power to that power there because the bases are the same. So having the bases, one base on one side and the same base on the other side, then we equate the powers, that is the n plus the negative 4 over n is equal to 0. So the plus and the minus gives us the result as a minus. Then now we are going to simplify the right hand side, or we multiply through by the LCM of the denominator. So when you multiply through by the n here, we have the n squared, then there the n will cancel out to have a minus 4, then n times 0, we have a 0 right there. Now we take the 4 the other side of the equation. Since it is negative, this side is going to come when it is a positive. Then from there we take the square root both sides of the equation. Then finally we get the value of n as positive 2 and negative 2. We have two values here, that is 1n is equal to a positive 2 and another n is equal to a negative 2. When we go to part E, we are having 2 power x plus 1 and then 3 power 4k minus 1. Now when you look at the right hand side of the equation, we have 108. So what we are going to do on the right hand side, we have to write 108 as the product of its prime factors. So since we have been doing that ladder method, you can try it out there, but when you prime decompose the 108, we shall have the 2 squared then times the 3 power 3. Then now, since we are having 2 appearing both sides of the equation, we are going to get the power and then we equate it to the power of 2 in the next step. That is the x plus 1 is equal to a 2. Then I take the other side of the equation to have x is equal to 2 minus 1. Then finally we get the value of x as a 1. Then I also come back and I equate the power of 3 on the left hand side of the equation to the power of 3 on the right hand side of the equation. So the 4k minus 1 is equal to the 3. I take 1 the other side of the equation to have 4k is equal to 3 plus 1. Then when I add on the right hand side, I'll be having a 4. Then dividing both sides by a 4, I'll have my k as a 1. We go to part F. We are having 2 power 2x plus 3 plus 1 to be equal to 9 into 2 power x. This equation is going to take us to quadratic equations. Let me hope you still remember the quadratic equations, how we solve them. If you don't remember, you can just go to the ordinary level mathematics videos and then you try to recall how we used to do those quadratic equations. So we are going to also first of all simplify, that is this 2 power x, we write it as a single 2 power x, then the power positive 3 is going to also be a multiplication of base 2 to power that 3. So this is what I'm trying to mean. We said that when we multiply these number bases, we write one base, then we add these powers there, which is we are trying to do the reverse. I can write this one as the 8, then also simplify this. I bring in the x inside and the 2 outside. Why? Because when you look at the right hand side of the equation, there is also another 2 power x there. So I'm going to let this 2 power x there to be equal to some unknown. So I let m to be equal to the 2 power x. Now where there has been 2x, I'm going to be writing there m. Now where there has been 2 power x, I'm going to be writing the m. So that is the m squared, because this 2 power x had a power 2 here. So the power 2 comes on the m, then times the 8 there, which was there. Then when we go to the right hand side, the 2 power x, we have said we are calling it now the m. Now when I try to rewrite the equation, multiplies the m squared to have 8m, then I take this positive 9m the other side of the equation to become a minus 9, then plus a 1. We said we have a quadratic term when solving quadratic equations, then a linear term, and finally the constant term. They move in that order there. So now we are going to identify the product, sum, and thereafter the factors of the quadratic equation. The product, the 8 multiplies the constant term to have positive 8 there. Then the sum, we normally get it from the linear term with its sign. That is why we are saying it is negative 9. And the factors there, we can formulate the negative 8 and the negative. When you try to multiply these two, we are having a positive 8. And when you try to sum them, we are having a negative 9. Then we are going to substitute these factors where the sum is. So the 8m squared, which was there already, then the minus 8m and the minus m plus the 1 to be equal to a 0. So we are going now to factorize two terms. We factorize those first two, and again we factorize those first two. Remember factorization, we are creating brackets within the factored terms. So when you look at these first two, 8m is common. So the next step, we are going to pull it out. And the next two, when you try to look at them, the minus 1 is common. So we are having 8m into the m minus the 1 and the minus m into the m minus 1. When you try to open the brackets again, the negative 1 will make the m to become a negative 1, just like in the previous, and the negative 1 again will make this, the multiplication of negative 1 there, to go back to a positive 1. That is why we are saying here that it's a negative 1, which is the factor. Then on the next step, we are seeing that this bracket and that bracket are the same. We are going to also factorize further. So the 8m minus the -1. So now we are going to equate each bracket to 0 to find the value of m. So the first one, when we equate it to 0, we are having 8m minus 1 is equal to 0. Taking the -1, the other side of the equation is going to become positive. Then dividing both sides by 8, we are going to be having m as the 1 all over 8. Now, this one here is not the answer. Remember, what we must find is the x. So I come back here, 1 all over 8, which is that. Then I try to simplify this one as 2 power 3. Then writing it in the numerator, the power is going to be negative. Then finally we state the answer as x is equal to -3. So I come back here for this other part to be equal to 0. When I take the -1, the other side of the equation, it becomes a +1. So m is equal to +1. Then I come back here to make sure that my is equal to now the 1. So the 1, remember now, it is the same as 2 power 0. Then I equate the powers and I get my x as a 0. So I'm having two values of x in this example here. I go to part G. The part G is 3 into 3 power 2x plus the 26 into 3 power x minus the 9 is equal to a 0. This one is just like the previous one. I'm going to find ways of making a 3 power x alone here in the bracket to be the same as the 3 power x there. Then I let it to be an unknown. When I pull out the 2 out, I'll be having the 3 into 3 power x, and then this power 2. Then now I let the 3x to be equal to my n. Where I see the 3 power x, I'm going to be writing there n, and also here I'm going to be writing there n on the next step. So that is the 3n squared plus the 26n minus 9 is equal to a 0. The product is going to be 3 times the -9 to have -27, like there. The sum is +26 here. Then the factors, we are going to be having the 27 and the -1 there. When you try to multiply these two, you have -27. When you try to add them, you have +26. So now I substitute my factors where my sum has been that one there, which is these two values there, the 3n squared, which was in the previous equation, then the 27n minus n minus 9. Now I'm going to factorize the first two terms and also those last two terms there. So the first two terms, the 3n is common. I factorize it out like that, and also the next two terms, the -1 is common. So even here, the n plus 9n plus 9 is common. Then I also factorize it further. When I factorize it further, I'll be having a combination of 3n minus a 1 into the n plus 9 to be equal to a 0. Then we are going to equate on the next part this to 0 and later on that one to 0. So either 3n minus 1 is equal to a 0. We take the negative 1 the other side of the equation to give us 3n is equal to positive 1. Then dividing both sides by 3, we have the n as a third. This one is not the answer. We recall that our equation had an unknown of x, so bringing it back here to be equal to the a third. The 3 power x is equal to a third. The a third is the same as 3 power negative 1, which is that. Then equating the powers, the x is equal to negative 1. When we go to the another part, that is the n plus 9, this one here, the n is going to be equal to negative 9, and that one there we cannot get the answer, or we cannot try to simplify it to have the answer. Therefore the answer is going to be invalid. And that is the end of the indices. So in the next part we shall talk about logarithm, then later on surds, and we continue with another chapter. Please don't forget to subscribe or try to share the video link with other members you study with, other friends of yours in different schools. So we meet again in the next lesson.